Welcome to the Deep Dive. Today, we're going deep, really deep, into the universe's shadows. We're tackling a pretty unsettling question, actually. What if something out there is watching us? But, not with light.
It's a fascinating direction, isn't it? Moving from, let's say, the known science of the invisible universe towards some really provocative ideas. Ideas that are still grounded in science, though. For this dive, we're looking at academic discussions, scientific papers, and also some interesting narrative bits from a piece called The Eyes of Dark Matter, Watching Without Light.
Okay, so let's kick things off. When we talk about the invisible universe, the elephant in the room is dark matter, right? It's just mind-boggling how much there is. Like, what is it, 27% of everything?
Yeah, about 27%. It's a huge slice of the cosmic pie, especially considering we can't actually see it.
Right. Completely invisible.
Completely. It doesn't give off light. It doesn't block light. It doesn't reflect light. Nothing with electromagnetism. And yet we know it's there. The how is all about gravity. Its gravitational pull is immense.
Ah, okay. So we see its effects on the things we can see.
Yeah.
Like galaxies spinning way too fast.
Exactly that. Galaxies rotate much faster than their visible matter stars, gas, dust should allow. They'd fly apart if that was all there was.
So something invisible has to be providing extra gravity, basically, holding them together.
Precisely. And another big one is gravitational lensing. You get these massive clusters of galaxies.
Yeah.
And the light from objects behind them gets bent as it passes through the cluster.
Okay.
And the way it bends, the amount it bends, tells us there's far more mass in that cluster than we can account for with just the visible stuff. That extra mass is dark matter.
So the evidence is strong, gravitationally speaking, but the mystery remains. What is this stuff? It's like knowing there's a giant hidden iceberg because you see ships steering around it, but you have no idea what the iceberg itself is made of.
That's a good analogy. And the candidates for what it could be are, well, they're pretty varied. You hear about WIMPs, weakly interacting massive particles. That was a favorite for a while.
Right, WIMPs. Still searching for those, aren't we?
Very much so. Then there are sterile neutrinos, maybe axions, these incredibly light hypothetical particles, or even primordial black holes formed right after the Big Bang.
Wow, okay. So a lot of possibilities, but nothing concrete yet.
Not yet. The search continues. But this leads us to the more speculative side of things. If dark matter forms these enormous structures, these halos around galaxies, these filaments connecting clusters, could it do more?
More than just sit there and pull things with gravity.
Exactly. Could it have its own complex dynamics, its own internal interactions?
That's where things get really interesting. I've heard mentions of dark sector forces. What's that about?
Right. So this is a theoretical idea. What if dark matter particles don't just interact via gravity? What if they have their own separate forces interacting weakly with each other?
Like a hidden physics just for dark matter.
Kind of, yeah. Similar maybe to how our ordinary matter uses electromagnetism to form atoms and molecules. Maybe dark matter has its own way of building complexity.
Okay, that opens up a whole can of worms. If it can interact with itself, could it form structures? More complex ones?
That's the implication. If these dark sector forces exist, you could potentially get intricate dark matter structures. Maybe even, and this is a big leap, forms of information processing. Things happening in the dark sector we're completely unaware of.
Whoa, okay. Information processing.
Which leads to that really provocative question. Could there be dark matter analogs to our senses? Ways for dark matter structures to perceive or map the ordinary universe, but using totally alien mechanisms, nothing to do with light or sound as we know them.
Dark eyes. So how would they see? If not light, then what? Gravity itself.
That's one possibility. Maybe they sense distortions in space-time gravitational waves. Or perhaps they sense subtle shifts in the dark matter density field itself, caused by the gravity of, say, a moving planet or star.
So their view of the universe would be completely different. A map of mass and gravity, not light.
Utterly different. And look, we know dark matter isn't perfectly smooth. Simulations show it should clump. Big halos, yes, but also smaller substructures.
Substructure, like smaller blobs within the big blob.
Exactly. Things called dark sibilos, little streams or clumps of dark matter drifting right through the Milky Way, potentially passing through our solar system even.
Okay, and we're trying to detect any interaction, right?
Yeah.
With experiments deep underground.
We are. Experiments like LUX Zeppelin, Xenon 1T, huge, incredibly sensitive detectors trying to catch a rare, faint ping if a dark matter particle bumps into an ordinary atom.
And so far?
So far, silence. Dark matter has remained stubbornly elusive, very quiet in our detectors.
But let's push that speculative envelope just for a moment. Based on that idea of structure and maybe internal forces,
Yeah.
what if you had an intelligent dark sector entity or civilization?
Okay, now we're really in the what-if zone.
Right. They wouldn't build like optical telescopes. Their view would be based on reading the fabric of space-time, tracing how mass moves, detecting gravity waves.
They might see the universe by mapping mass distributions, feeling the gravitational ebb and flow.
Which means they could be watching us without light. They'd perceive the movement of mass planets orbiting, ships launching, maybe even large-scale movements on Earth, things we can't hide gravitationally.
It's a mind-bending thought. And if dark matter can support that kind of complexity, potential information exchange, well, it really challenges our definition of life or intelligence or consciousness. Our understanding might be incredibly biased by our own ordinary matter perspective.
So the implications are huge. Could there be these dark matter observers, totally alien, for whom our bright, visible universe is just like ripples in their reality? Could our actions, even small ones if aggregated, create signals in their gravitational sense, like the hum of a city or the collective movement of people?
It makes you wonder what constitutes a signal in that context. Could the launch of a rocket or even something like plate tectonics register clearly to such an observer?
Or the alternative.
Or the alternative. Perhaps dark matter is just stuff, passive scaffolding, a huge, inert cosmic skeleton, completely unaware of the little sparks of ordinary matter life flitting through it.
Just cold, dark matter.
Right. And it's important to stress, while this sounds like sci-fi, these kinds of questions about the nature of reality, observation, consciousness, non-standard life are genuinely being discussed by physicists, philosophers, astrobiologists. Because the mystery of dark matter forces us to confront the limits of our knowledge. As we build better detectors, better gravitational wave observatories, maybe we're not just mapping the universe.
Maybe we're also somehow being mapped.
Being seen.
Yeah. In the end, dark matter is this great unknown. Maybe it's a mirror, reflecting our own assumptions back at us, forcing us to question what reality even means.
So it leaves us with some profound thoughts to chew on. What is reality when most of it is invisible to us? What does observation mean if you don't even need light? Something to keep pondering as you look up at the night sky or perhaps feel the space around you. Keep your minds open to the unseen cosmos.